Hello and welcome to my demonstration of the Panadent articulator features and accessories. Panadent has two main articulators. The PCH articulator, which is a curved incisal pen which is calibrated in degrees. It is half a degree increments, so each half a degree line is approximately 1 millimeter. The straight incisal pen, or PSH articulator, is calibrated in millimeters. The difference between the two is mainly where the pen touches the incisal table with a curved incisal pen will remain in the same position and angulation at different vertical dimensions of the articulator. Where with the straight incisal pen articulator, the incisal pen will move forward and back at different vertical dimensions of the instrument. Otherwise, the features are basically the same. If we look at the guide system, which is the foundation of the Panadent articulator based on my father's research of actual patients' job movements, it is a curvilinear guide system. And if we look at this guide system, we can see that there's a lateral working movement, then there's a straight protrusive movement, and a curvilinear bending movement. So if we go to the grease board right now, we can look at this. In most articulator guide systems, there's three main types. They'll have a working side movement here. They'll have a point centric, come straight forward, a point protrusion. And then they have an undercompensated guide path that comes out to point bending. This will lead to positive errors. And that's because the patient will actually chew beyond the limitations of the articulator in a curved pathway like this. So if the patient chews beyond the limitations of the articulator, anything between the articulator line, the blue line here, the articulator line, and where the dotted line where the patient moves is a potential posterior interference. So what they did is develop the immediate side shift articulator, where you have the working side here, the point centric, come out to point protrusion, then they came out to point side shift here, and then out to point bending. And what they did is that creates a negative error, because the patient will then chew within the limitations of the articulator. But if you have 2 millimeters of side shift here, it's only 3 millimeters from the central fossa to the cusp tip. Therefore, 2/3 of the tooth would be as flat as this floor. So this little triangular area in here is anatomy. So what we want is a curvilinear pathway like we have with the Panadent. We have point centric, out to point protrusion, and then we have a curved Bennett pathway. And this will help us reduce or eliminate the possibilities of interferences, but still maximize anatomy for chewing efficiency and stability. Now, if we look at the side of the articulator and the scale here on the side, we can see that we only use arbitrary numbers. And people ask, why do you only use arbitrary numbers? That's because there is no such thing as an angulation in a curved pathway. It all depends where you are on this pathway will give you different degree angulations. Now if you look at the scale here, you can see that we do have 29 degrees at the number 2 position. We have 45 degrees at the number 6 position, and down here number 12 is 69 degrees. Each line represents 4 degrees. Where we actually index this degree angulation is where we measure forward 1, 2, 3, 4, 5 millimeters forward. That's when you're basically edge to edge in protrusive movement. Come straight down to where that intersects the line, and then that will create our degree angulation. Now with the curvilinear analogs of motion, we do have the centric latch here and back, which will help keep us in a positive centric. But when you release the latch, we can now go through excursive movements. And the dynalinks here on the side keep the axis elements tracking that medial wall automatically for you. And you can see the smooth transitions as it moves from one plane to the next, more simulating lifelike chewing motions. We do have the second pin here, which is a support pin, so when we open this up 180 degrees, it won't fall back on us. We also have the little articulator support legs, which we can add to the articulator by just clipping onto the lower frame on both sides. And that'll tilt the articulator back for patient consultations or for even photography procedures. We also have a little rubber band here on the bottom, which we can come up and help hold that latch out of our way for different procedures that we may do. So we can release that. The incisal table. It's rhomboid shaped like Posselt's rhombus. That's because with the curvilinear analogs of motion, that's the way the articulator moves, simulating Posseld's rhombus, more lifelike chewing motions. Now, if you want to create a customized incisal guide table, you do not have to create undercuts here in the incisal table to keep the acrylic in place, destroying your incisal table. We do have a little lip around the incisal table, so we can lubricate this with a little Vaseline, put some acrylic in here, then we can mold out our table, and then we can either sticky wax it in place or remove that customized table and then re-index it at a later date. We also have an adjustable incisal guide table, so we can remove the standard incisal table and we can add the adjustable table. On the bottom here we do have two screws. The little screw will tighten the complete housing to the articulator. The largest screw is a screw for adjusting the incisal guidance here, and so when we tighten that up, it'll hold that in place for us. We also have screws here on the side that we can adjust for different canine guidance. So we can see how we can adjust this for both incisal guidance as well as for canine guidance in our adjustable table. And that'll help create a guide system for the articulator. Now, since this table is higher than our standard table, we do need to replace the incisal pin with the shorter shovel point incisal pin. So we'll put that in place, we'll tighten in place, and now we're at the proper vertical dimension for this incisal table. And now we can move the instrument, and the lateral wings will help create a canine guidance, and then the incisal guidance into the table this direction. So we can go ahead and remove this table now at this time, and replace our standard table, and then I'll go ahead and replace the standard incisal pin. Now I realize that my mounting plates are constant to the axis irregardless of where the models end up. So what we did is we created a little box here in the back of the mounting plate to create a secondary receiving port. That is so when you first mount the models to the full-size Panadent, you can then remove this model and then you can come with the little PAL articulator and clip it into the receiving port. Remove the lower model and clip it in. Now the PAL articulator has the same axis of rotation as the full-size Panadent. It also has a built-in support stand, and it will flex into lateral movement as well as protrusive movement. You can open past 90 degrees, you can separate the frame, then you can reconnect it. It does have horizontal and vertical aesthetic alignment guides built into the back of the articulator. And then when you're done, you just simply push the button here, which will release the models, so you can go back to the full-size Panadent with the curvilinear analogs of motion to do any quality control or final adjustments. And the way we manipulate the articulator is by releasing the centric latch, and then we disclude like the patient does by simply opening their mouth. Then we come to a canine side and work our way back into occlusion. Open, come to a canine, and back into occlusion. Open, go incisor movement, and then back into occlusion. So we can evaluate, do we have any interferences from eccentric movements back into full occlusion. It just makes it very easy to diagnose. And if you look, the Dynalinks keep everything tracking that medial wall automatically, simulating those lifelike chewing motions. We also have analog selectors. The analog selectors can be put in place of the motion analogs and used with lateral check bites to determine the amount of Bennett movement. We do have different size analogs of motion ranging from 0.5 to 2.5 in half millimeter increments. This here is a 1.5 millimeter curvilinear Bennett movement analog. We also have Condyle Positioners. Condyle Positioners are used for simulating model surgery or making repositioning splints. The way we use those is first we loosen the screw here on the analog to release our Dynalink pins. Put them in the storage hole, then we can remove our upper frame. We do have the rubber band here on the back that we can come up and hold our latch down out of our way. Then we have the little lock set screws here in the back of the upper frame where we can loosen those up. And then we can loosen the thumb screws on top so that we can remove our motion analogs. We can then replace them with our Condyle Positioners. And if you look at the Condyle Positioners, we do have a screw here, and I'm not sure if you can see it, but there's a line on the screw that will correspond with the line on the housing. When the screw is flush on the inside and the lines line up, that's centric position. There's also a line on the screw here on the back as well as on the housing. There's also 1mm lines on the shaft so we can do lateral shifts as well. So I'm going to put these in and put it up to the furthest line towards the housing. So I'm going to put this in and adjust it to the furthest line and tighten it in place. Then I'll add the other side. Adjust it all the way up to the furthest line towards the housing, and I'll tighten that in place. Now we can add the frame back to the articulator, and one rotation of the screw equals 1mm. So if we want to loosen the little lock screw here and turn this 1mm, we can turn that one rotation, and doing that on both sides would be like impacting the maxilla. If we adjust the screw here in the back forward, we can loosen the lock screw and screw it forward, it'd be like an advancement of the mandible. And then again, we can loosen up the screws and do lateral shifts if we want to as well. So these condyle positioners, or for jockeying the condyle around to different positions to simulate model surgery, or to move it into a different position for making a repositioning splint. So we can go ahead and remove the condyle positioners. We can add back our motion analyze. And we'll lock them in place with the set screw. Now if you notice here, there's also a little half moon effect here on the bottom of the centric channel, which means if I tighten the screw down real tight, it'll pull the center down and actually squeeze the size inward. So this centric channel is adjustable. So if you over tighten the button screw, the centric pin will not slide through the channel well, so you may need to adjust that slightly. Now we also have an articulator test column. The articulator test column is basically a metal column that we can index to the lower frame. And then we have a mounting plate that'll go to the upper frame. And then we have a little plaster retainer ring. And then we'd spray this with a silicone lubricant spray or a separating medium. Mix up a good dye stone, put it in the mounting plate, fill this up to the top here, and then we'd swing this around, making a connection of the two plasters. Once that is set, you end up with a plaster index like this. Then the plaster index will then index through the upper frame to the test column at the lower, and then we can check the accuracy of the articulator from time to time to see if we're still in calibration. If it's out of calibration, you need to send it back to the factory to recalibrate. Because we actually calibrate the axis of our articulator. We have a special jig that will hold the axis perfectly up and down, side to side, and forward and back, so that not only our centric position is accurate, but any movement, because all the movements take place around an axis, they'll also be accurate. So that's the articulator test column. Now we also have a Broderick occlusal plane analyzer. The Broderick occlusal plane analyzer has this Broderick flag, and we add that to the articulator by removing our reference flag here from the articulator. And then we can add our Broderick flag to that location. So we tighten that in place. Then we have these little clear acetate overlays that we can index to the little indexing pins here on the side of the Broderick flag. And that's in place. Then we have a compass, and we'll index the compass to the edge of the plate here, and then we'll adjust it out to the 4-inch mark, which will correspond with Bonneville's equilateral triangle or Monson's spherical theory of 4 inches. At that point, then we can add a lower model in here, and then we take the compass and index it to a canine cuss tip here, and I'll just hold that in place, and we go ahead and scribe a line onto our Broderick flag. Then we come back to a molar cusp, and we scribe a secondary line. You can see the two lines intersect. We can then re-index the point to that intersection there, and then we can scribe this along the occlusal surfaces of the teeth to evaluate the curve of speed or the occlusal plane of the mandibular arch. If you do not have one of those two teeth to index those, we can also use an axis point. By doing that, we have to remove the upper frame, we have to loosen the lock screw here in the back, and then we can loosen the thumb screw on top, remove the motion analog, and replace it with our orientation shaft. We can then put this back into the articulator, re-engage our centric latch, and then we want to pull this extension pin out until it engages the axis element here. And then we'll go ahead and lock that in place with the screw. Now with our compass, we can remove the little point here and replace it with a little cut point. Then we can use that cut point on the side of the axis element here to scribe our third line if we need to. And then that's the Broderick Occlusal Plane Analyzer. We'll go ahead and remove this from the articulator and remove our extension shaft and replace our motion analog and lock it in place with the lock screw. Add this back to the articulator, re-engage our centric latch, re-engage our Dynalink pins, remove our Broderick flag, then we can replace our reference flag. We'll get it in place there. Got that in line. You can add back our upper pass. And that concludes my demonstration of the Panadent articulator features and accessories. Thank you.